Hey everyone, my name is Dushyant and I am currently pursuing B.Sc honor in Data Science and AI at IIT Guwahati. This video is the project submission video of my course DA377. In this project, I developed an AI lecture assistant using Whisper embedding and retrieval augmented generation. The goal of the project to make long lecture video searchable, accessible and easier to understand using AI technology. So let me begin the presentation. So let me introduce the project. Nowadays, most educational lecture and videos are available online in form of long lecture videos. Although these lecture videos are very informative, but students often face difficulty while searching for a specific concept inside them. Students spend their lot of time by manually navigating through these long lecture videos. Also, traditional keyword-based search system cannot properly understand the actual meaning and context behind them. Recent AI technology like Whisper, embeddings, and large language modules can help solve this problem more efficiently. Therefore, in this project, I developed an AI lecture assistant that converts a lecture video into searchable and summarized educational content. So let me discuss the problem addressed in this project. Nowadays, educational platforms contain a lot of videos lectures. For a student, finding a specific topic or concept inside these videos lectures are very difficult and are very time consuming. For example, if a student wants to learn a topic like pitch estimation, ZCR, they may need to manually go through the entire lecture to find that topic. Traditional keyword-based search system cannot understand the semantic meaning. Therefore, this project aimed to build an intelligent lecture assistant that capable of understanding the natural language query and retrieve the most relevant lecture content automatically. So let's move to the next slide. So let me explain the let me discuss the objective and technology used in this project. The main objective of this project to convert lecture videos into searchable educational content. Another objective was to generate a lecture transcripts using Whisper. Whisper is a speech-to-text model used in this project. After transcription, semantic embeddings are created for intelligent lecture search. Cosine similarity was used to retrieve the most relevant chunk based on the user query. In this project, I used technologies such as Python, React, Fast API, Whisper, Olama, and scikit-learn. I also used Qwen 2.5 model for AI-based response and MXBA embedding laws for creating embeddings. So let me explain the overall workflow of the project. The workflow starts with the lecture videos, which are provided as input. Then in step second, I extract the audio from this lecture video using FMPEG. Then in step 3, Whisper converts the audio into text transcript. After that, the text is divided into smaller chunks. Then in step 5, these chunks are merged together to maintain a better context. Then in step 6, embeddings are generated for these lecture chunks using MXBA embedded large model and stored in a file. Also, when a user asks a query, query is also converted into embeddings. Then I use cosine similarity to compare the user query with the stored lecture embeddings and retrieve the most relevant chunks. Then these chunks are sent to the Qwen 2.5 model through a RAG pipeline. Finally, the system generates AI-based response and display it on the front. So let me explain the core technology used in this project. First, I use Whisper for speech-to-text transcription. Whisper converts lecture audio into accurate text transcription along with the timestamp. Then the lecture text is divided into smaller chunks, and these chunks are converted into embedding using MXBA embedding large. Embedding is basically a numerical representation of text that helps system to understand the semantic meaning. Also, when a user asks a query is also converted into embeddings. Then, cosine similarity was used to compare the user query with the stored lecture embeddings. Based on the similarity score, system retrieved the top relevant chunks. Together, whisper embedding and semantic search form the foundation of our AI lecture system. So let me explain how the system generates response using RAG. First, First, the user asks a question in natural language. Then, the query is converted into embedding and compared with the stored lecture embedding using cosine similarity. Based on the similarity score, system retrieves the top relevant chunks. Then, these chunks are added into the prompt along with the user query. Then, the prompt is sent to the Qwen 2.5 model. Then, the model generates AI-based response using retrieved lecture content. This helps the system generate more accurate and context-aware answers. So let's move to the next slide. So let me demonstrate the front-end interface and result of the project. The first screenshot shows the lecture search interface, where the user asks a query in natural language. Then the second interface shows AI-generated search response along with the lecture information and the timestamp. Also, the system retrieves the post-relevant chunks and generate an explanation based on it. Oh, and the third screenshot demonstrates automatic automatic summarization, where the user enter the lecture number and enter the lecture name. It will generate summary for the entire lecture. Overall, the front-end provides a simple and user-friendly interface for our intelligent lecture system. Now let me discuss the limitation and future improvement of the project. The one limitation is that the processing long lecture videos takes more time, and another was to large transcript files can also increase the storage requirement. The retrieved accuracy depends on the quality of embedding. Running large language model locally requires a better hardware resource. In some cases, background noise can also affect a transcription quality. In future, this project can be improved by adding multi-core support, voice-based lecture search, real-time lecture processing, better supervision quality. Vector database integration also be added in future version. Now let me conclude the presentation. In this project, I developed an AI lecture assistant that using whisper, embeddings, and cosine similarity and retrieval augmented generation. The system is capable to convert lecture videos into searchable and summarized educational content. It can retrieve relevant lecture resources, generate AI-based response, and provide automatic lecture summaries. Overall, this project demonstrates how AI can improve lecture accessibility and helps students to learn more efficiently. So, thank you for listening me and bye.